This is Principles of Ecosystem Ecology. Chapter 13. Landscape Heterogeneity in Ecosystem Dynamics. In the previous chapter, we had started to think about temporal dynamics of ecosystems, how ecosystems, the processes of ecosystems change over time, and how they respond to individual events. In this chapter, we're going to begin to look at spatial variation in ecosystem processes, and not just how ecosystems differ, but also how processes interact across what we consider to be ecosystem boundaries and affect the functioning of individual ecosystems. Spatial heterogeneity within and among ecosystems affects the functioning of individual ecosystems and entire regions. If you remember, we had two criteria for thinking about how to define the boundaries of ecosystems. The first was a localization of interactions. So when we take a look at all the interactions that occur within a space, we might find a localization where interactions tend to be more concentrated. When you use that approach, you would come up with the definition that an ecosystem is a localization of interactions between organisms and their abiotic environment. The other definition that we have for defining the boundaries of ecosystems is really based on patterns of similarity. When you do that, you state that an ecosystem is an area that has similar ecosystem processes as other areas. And this is primarily for scaling purposes. We might find a relatively homogenous patch, do measurements there such that we can extrapolate over a broader area, assuming that we have more or less similar patterns. Just in the same way that when we do a measurement, we want to extrapolate over time, we find a time that seems to be relatively representative over longer periods. So the key for thinking about ecosystems and studying individual ecosystems is really to find homogeneous patches where there's localizations of interactions. And they don't necessarily have to be homogeneous, but looking for those localizations of interactions. That being said, there's interactions among ecosystems. And these might be relatively weak compared to the functions within the ecosystems, but there's still factors that link individual ecosystems. So that might be movement of animals from one patch to another, for example, but the dynamics of what occurs in one patch are going to affect the dynamics of another patch. So thinking about that, the spatial pattern of ecosystems in a region likely is important. It also allows us to extend this approach to broader and broader scales in using these homogeneous patches. So here, in the introduction, thinking about the spatial arrangement of ecosystems and how they interact, the chapter is going to cover three different factors. First is going to be the concepts and characteristics of landscapes. And extending that ecosystem approach to the landscape approach, getting from the plot level up to the broader landscape to regional pattern, is something that's relatively novel in ecosystem ecology and incorporates a range of what were earlier considered weaker interactions. Secondly, we're going to go over the sources of spatial heterogeneity within and among ecosystems. So spatial patterns and differences among ecosystems can be captured with thinking about the heterogeneity of those different ecosystem processes. So we're going to think about that within and among ecosystems. Lastly, we're going to focus in on the consequences of spatial heterogeneity for interactions among ecosystems. So it's important to know for a given ecosystem what the variation in processes might be within there, but also realize that ecosystems exist on a landscape and there's interactions that occur at broader scales. And those interactions, generally over longer time scales, are very important. A focal issue for this chapter states that human land use change has fragmented landscapes throughout the world, often shifting the balance so that managed patches become a widespread matrix in which small fragments of less managed lands persist. So, for most of the history of life on Earth, disturbed patches or patches that were areas where humans had had effects were relatively small in a broader matrix. These days, in many parts of the world, it's the native systems, the natural systems that have less of a human impact that exist as isolated areas within a matrix of areas dominated by humans. So we had a previous example of thinking about clear cuts in the Northwest, and you can see that we have forests that are in various stages of regrowth, and we have patches that have been clear cut. Now this, to a certain degree, can be thought of as mimicking a natural disturbance regime, but that being said, we have to understand now that if we want to understand an individual patch, be it a clear-cut patch or more intact forest, we have to understand the matrix that these exist in. The authors show a similar pattern in China, where shifting agriculture in the uplands of a province in China as a result of pressures of rising populations. And here, what we have is that there's been changes in the shifting agriculture that has existed over time. And lands that previously had remained forested and out of agriculture for a relatively long period of time are now being rotated into agriculture over shorter periods of time as the demand for food increases. That's a change in how this system works, and the consequences for that, for the vegetation, as well as nutrient cycling, water cycling, ecosystem processes like those, are still unknown. So some of the key questions here to think about as we broaden out the importance of the questions in this chapter. As global demand for food increases, how do we manage landscapes to meet these needs and to sustain the functioning of natural patches in the landscape? So if the matrix in a system is primarily agriculture, and you have a relatively small patch that would be native for all intents and purposes, how well does that system function in the absence of a broader matrix of natural ecosystems? And how do we manage the landscapes to maintain the integrity of these systems? This is probably just as an important question, or even more. What are sustainable proportions of lands of different management intensity? So when we go through, if you take a drive in an agricultural region, for example, that you'll see that the broader matrix, almost everything from road to road, is going to be divided up into fields. And native vegetation is relatively rare on that. What we don't know, for the long-term sustainability of the system, do we have to take areas and maintain them in a native state? And if so, what percentage of areas need to be maintained in a native state, or at least at low management intensity? This is a question that we just don't understand. Do we have to designate 5% or 10% of the lands as not being touched in order for them to be long-term sustainable? Sustainable on not just decadal scale, but on century scales, if not millennial scales. Lastly, what configuration of natural and managed patches best meets the needs of nature and society? The arrangement of ecosystems is probably just as important as the overall proportions. So if we say that, for example, we need 10% of an area to be in native vegetation, does it matter if it's one block in the corner or smaller blocks throughout the whole area? What does that configuration of different ecosystem types need to be and for different purposes? If there's interactions between native and managed ecosystems, having them sequestered into one portion of the ecosystem might not provide the same benefits if they're distributed. On the other hand, if they're distributed in smaller chunks, they might not be sustainable over longer terms and have the same degree of functioning as larger patches.